this video, we're going to talk about why high efficiency furnaces can be so unreliable and some of the most common causes to check for if you're ever having issues. The truth is, as much as I hate to admit it, every time we are having issues with a high efficiency furnace, 9 times out of 10, it's installation error, because although these are more efficient than your standard 80% furnace, they can be finicky if they're not installed properly. And this is especially true at high altitudes because the exhaust sizing requirements and how they interact with the pressure switches inside the system get increasingly more demanding. But we will talk about all this and more in this video. And if you're tuning into this channel for the first time and haven't done so already, please consider subscribing and make sure you smash that like button before we get started. Now, the reason that high efficiency furnaces have a reputation of always breaking and being unreliable is because if they are not maintained properly, there are a host of issues that can arise. There's another video on our channel that explains how high efficiency furnaces work, so I'll make sure to link that video at the end, but I will touch on that briefly here so you understand where all these issues come from. The only difference between an 80% and a 90% efficient furnace is that a 96% efficient furnace has what's called a secondary heat exchanger. This secondary heat exchanger is where the extra heat energy is pulled out of the exhaust gases before leaving the building, and a byproduct of this combustion process is actually condensation, because what results is that you have a much cooler exhaust temperature, and this is where all of the problems start. Now, a normal 80% efficient furnace does not have condensation in the exhaust because it has not gone through a condensing heat exchanger like you have in a 96% efficient system. One of the most common codes that you see on a furnace that is high efficiency is what's called a pressure switch error code, and the pressure switch is measuring pressure inside of the heat exchanger and the exhaust circuit, and it's essentially just a proving switch to make sure that the fan is kicking on and the exhaust isn't blocked. Now, when the pressures are correct, the switch opens or closes depending on how it's wired, because some switches are normally open and some switches are wired normally closed. But when you see this, what it means more often than not is not that there is an issue with the pressure switch, but that there is an issue in the exhaust circuit or the condensate trap is blocked. But if it's a chronic issue, it could be something as simple as the furnace not being tilted forward at an angle or at the right angle to make sure that the heat exchanger itself is draining properly. So we will talk about some of the things that need to be done as far as installation best practices on a high efficiency system to make sure that it works reliably, as well as some of the maintenance items to make sure that your system works trouble-free on a consistent basis. The two biggest maintenance items that will prevent all issues in HVAC in general, but especially with high efficiency furnaces, is number one, cleaning out the condensate trap. That's specific to high efficiency furnaces. And number two is changing your filter. Changing your air filter is a DIY item that most homeowners can do. However, the condensate trap is something that should be cleaned out by your technician during yearly annual maintenance. If you've never had maintenance on your high efficiency and it's been working reliably, you're definitely lucky, but condensate traps normally start clogging if they don't get maintenance after 3 to 4 years in my experience. And this is because sediment and dirt and debris can build up in that trap and cause the condensation to back up into the furnace and drain slowly, which is how you get that pressure switch error code that I just mentioned earlier. Now, there are several chronic issues that we see that are a result of installation error, and I will touch on these now. Now, number one is using the wrong exhaust size. The way that you size an exhaust is based on a combination of the length of the exhaust as well as how many 90s or 45-degree elbows. The reason that this is so important, especially for us in Colorado, is that at altitude, the air is thinner up here. And if you have the wrong size exhaust, it will cause chronic pressure switch error code issues. And in order to size things properly, it's very simple to do. You just look at the manual, because in the manual, there's going to be a page that tells you exactly how to size it based on the specific model and BTU rating of the furnace that you're installing. Another thing that causes high efficiency systems to fail is improper exhaust slope or termination, as well as where the condensate line terminates. Now, if you have a floor drain, then you will just gravity drain your high efficiency furnace into the floor drain. But if you don't have a floor drain in the mechanical room, then you will be using a condensate pump to pump the condensation outside. Now, this condensation will freeze on very cold nights because it's just water, and that's going to happen where it exits the building if it is not insulated against cold. And the condensate pump is backed up. It will then trip a float switch inside of itself that then turns off the furnace. And this is a really simple fix, and it can be avoided just by making sure that the condensate line itself is insulated against the cold. One of the ways that we do this is making sure that it's inside the insulation connected to the exhaust termination, because by running the condensate line through the same insulation as the exhaust, there is enough ambient heat from the exhaust to keep the water from freezing on cold nights, and therefore keeps your system running. Now, as far as the exhaust slope is concerned, the codebook states that you want a 1/4 inch per foot of slope in your exhaust, and you want it angled back towards the furnace so that the condensation drains back to the furnace when it is running. And the reason you want it this way, not perfectly level, or even worse is to have negative slope somewhere, is that you will create a pocket and a puddle of water in the exhaust that will back up the exhaust to a point that the pressure switch air code pops up again, and the furnace will not run until some of the moisture dries up in that section of the exhaust. This is another reason that a reducer in a horizontal section is a big no-no unless it's an eccentric PVC reducer, because these allow water to drain even in a horizontal section, and that's their purpose. And the other consideration on the exhaust is the termination. The code says that you want these terminated at least 12 inches above the highest level of snowfall, but if you have an eye that is blocking where the exhaust and intake terminate, then this may not be applicable in your situation. For example, if snow doesn't pile up on the ground to the extent that it could block the exhaust, then it might be lower than this. You know, it might not be a problem, is the bottom line. But the big thing is that the intake and the exhaust have to be able to communicate freely with the outdoors in order for your system to function properly and to have enough combustion air. So again, if you have an eave that's blocking that, then you're probably fine. And I'll talk about 3 more things that cause a lot of issues on high efficiency furnaces. But before we do that, if you're enjoying this content, please smash that like button if you haven't done so already. And if you're having issues with your high efficiency furnace, we do provide service in Denver as well as Phoenix. So just keep that in mind in case you're in need of immediate service. We're also expanding to other states soon. So just keep that in mind that we do offer that. And these last 3 installation best practices or installation error issues are some of the most troublesome because they are so minor, but I still want to touch on these. Now, number 1 is basic, and that is system sizing. If your furnace is too big for your home, oftentimes I've seen people put in furnaces with something that was sized based on the prior furnace, and this is not at all how you want to size your system, at least not primarily. I always assume the guy that installed the furnace before me is privately filming me, and I'm about to be on an episode of HVAC Punked after installing the new furnace, assuming that the existing furnace was the right size and working fine. But 9 times out of 10, they are, but occasionally we do run into systems often where they were oversized before, and we can get by with a smaller furnace. In the world of HVAC, bigger is not better. You want a Goldilocks system that is right sized for your home, just so that way it has longer run times in order to maximize efficiency. And this is also going to minimize the wear and tear on the system. And this next installation error is a gotcha that is so minor and easy to miss that oftentimes we have new technicians at our company that will miss this on their first high efficiency install. And this is why we train all our guys to look for this, because it will cause so many problems and be difficult to spot. And that is that you want to make sure your furnace is tilting slightly forward so that it can drain properly. Now, the furnace itself should have a little bit of slope tilting towards the front of the furnace because you want the condensation in the secondary heat exchanger to drain effectively out of the system. If you don't do this, it might work sometimes or most of the time, but then on the coldest nights of the year when you're getting those longer run times, suddenly the system will stop working because enough condensation built up for it to throw a pressure switch air code because it wasn't draining properly. The bottom line is this is a common error, but the good news is it's very easy to fix. Normally you are able to just wedge up the furnace and tilt it forward ever so slightly, and it will start draining effectively right away. One trick to watch out for sometimes is that the basement floor where the system is installed is not even level. So although you might look at the furnace and think it looks level, it might actually be tilting backwards because the basement floor is uneven or because you've had foundation settling. And this is why we always put a level on the furnace as a simple check to make sure that things are working properly, because if we don't, we might have issues. And the last thing to check is that one of our installation best practices is to do a combustion analysis. This isn't true on all systems because the modulating systems and 2-stage variable speed systems that ship, at least from Daikin, ship with a sticker over the gas valve that says do not adjust gas valve. But if you put in a basic single-stage system or a basic 2-stage system, then you will still normally need to do a combustion analysis just to make sure that it's burning efficiently. When we do a combustion analysis, we're looking for low levels of CO in the exhaust, so that way you know you are getting a clean and complete burn, and it will actually tell us right on our combustion analyzer what the efficiency is running at. And there's a video we put out about the triangle tube instinct combi boiler a few months back, and I put a combustion analyzer in the boiler to showcase its efficiency. And modulating systems like that, you're basically just doing it as a check because you have an electronically modulating gas valve that is doing all of the tuning for you. Single stage systems, on the other hand, you'll need to tune by hand and by adjusting the gas valve. And the bottom line is that this is something that we check because if a system is running rich or lean, it will cause problems down the line, and it's just something we do to make sure that the system is running well. And if you happen to be in one of the areas we service, like Denver, Colorado, or Phoenix, Arizona, you can actually schedule an appointment with us for free. We come out for free for all first-time customers, whether that's for a service call or annual maintenance, or if you're just looking for an estimate for system replacement. And there's actually a link in the description below where you can actually schedule online at your convenience, as well as an up-to-date list of the cities and states that we service, so you can stay up to date when we start servicing your metro. And as mentioned earlier, there's a few videos popping up on the screen right now, so make sure you check those out if you haven't done so already, and we'll catch you on the next episode.